In this video, we're going to talk about similar triangles. And the first theorem that we're told is this angle-angle or AA similarity. And all it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And this one squiggle is pronounced similar to. Okay, so let's take a look at a quick example on how to use this. Okay, so our first example is going to be given these two triangles, and we're supposed to determine if they're similar or not. And based on the theorem that we have here, I can see that I have one pair of angles the same, but not the other two. However, that doesn't mean that they're not similar. We've got to find the other missing angles in both triangles in order to really see this clearly. So we're going to go through that process real quick. So over here, I need to add the 48 and 57 together, and then I need to subtract that amount from 180 degrees. So I didn't write this very well, but there we go. 180 minus that sum, which gives me 75 degrees. So as soon as I see that, I now have two pairs that are the same. So we're going to say that these two triangles are similar. And the way to write that out completely is we're going to say triangle JKL is similar to triangle, and then wait for a second. Okay, we have to go in the same order as the triangle that we just listed. Now, angle J was the one set with 48 degrees. That's going to be our Q over here. So that needs to go first, since that's the first letter that's in my first triangle statement. The next angle I listed was K, which is the 75 degrees, which for the next one is angle P, and then the last letter, which is M. So that's how we're going to state that all together. So our next theorem is called side-side-side similarity. And you can abbreviate that as SSS, and what this says is if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay, so here's our example. It says, determine if the triangles are similar. If so, write a similarity statement and explain your reasoning. So in this picture, we have this diagram that is constructed off of two triangles. And the way to compare them is to find the corresponding sides, like what it says in the theorem itself. So the way to start this is you can start in descending or ascending order, so smallest side to bigger side, or vice versa. I'm going to start with the smallest side, and on the small triangle, that's going to be 5, and then the small side on the large triangle is 12.5. Okay, so that's going to be my first ratio. The next one I have to determine is the next biggest side, the medium, so 6 over, and then the medium-sized one on the larger triangle is 15. And last but not least, we have to check the largest. The small triangle is 8, the large triangle is 20. And we are just going to divide these or simplify them as best as we can, and then we will see if these are proportional. So we can see that all of these actually come out to be the same value, which means that they are similar. These two triangles are similar. So in the first part of the question, determine if the triangles are similar, we've done that. The next part is, if so, write a similarity statement. So this is where we're going to do the triangle part similar to another triangle part. Again, make sure that you're going in the correct order. So for the small triangle, I'll say that it's P, Q, R. Now, the P, okay, this angle here is in between the medium and largest side. Down here, the angle that's in between the medium and longest side is S, so that's going to be written first. Angle Q is drawn between the smallest and medium, so down here, my small to medium is right here, so that's going to be angle T, and then the remaining letter of R. So this is our similarity statement. We can check that off our list. Explain your reasoning part. First of all, your work, your shown work is part of that. So here's a part, and those two as well. And then what you want to state is the theorem that you used. So I would say the theorem of side-side-side similarity. And that explains your answer. All right. Okay, so our next theorem is side-angle-side or SAS similarity. And this one is a mouthful, but I'm going to show you how to use it. It says if the lengths of two sides of one triangle are proportional to the two corresponding sides of another triangle and the included angles are congruent, then the triangles are congruent. What it means by this, I'm just going to do a quick picture here for you. Not like that. So basically what it says is if this side and this side are proportional, and this side are proportional, and the angle in between them are congruent, then the triangles are similar. So this is a pictorial version of what this is saying. And we're going to take a look at an example to see exactly how to use this. Okay, so we're going to have the same exact instructions as the previous problem. We're going to determine if the two triangles are similar, and if they are, we're going to write a similarity statement, and then we're going to explain our answer. Please be aware that in this picture there are indeed two triangles. There's the smaller one up top, right here, and then the larger one as well, which is the complete outline. So what we need to determine is if the corresponding sides are proportional first. So on the smaller triangle, we can do, the smaller side of the small triangle is 8, okay? And then the small side of the large triangle, we actually have to do a quick calculation first. So the entire length of AC is the sum of those two parts, which is 12. So just be careful with that. And then the total length over here is going to be 15. So when I'm comparing 8 to 10 in the small triangle, 8 is the smaller side, and on the large triangle, that small side is 12. So that's what I'm going to compare it to. And then I'm going to do the same thing with the longer side. So 10 is the longer side of the small triangle, 15 is the larger side of the big triangle. And we're going to evaluate these real quick to see if they come up with the same value. And sure enough, they both reduced to 2/3. So far, so good. Now we have to figure out this angle business. And notice that the two triangles actually share the same included angle, which is angle A. This angle is an included angle because it touches both of the sides that we have. So because A is congruent to itself by the reflexive property, we actually have that already taken care of. So angle A is present in both triangles. We've got our included angle to be congruent to itself. So everything matches this side-angle-side similarity theorem, so we can go ahead and make our similarity statement. So again, this is a tricky part. You want to take your time. So I'm going to name the small triangle first. I'm just going to go AFE is similar to, and then of course we want to be careful about how we name the second one. So angle A is the angle that we are starting with in both triangles, so we can do that here. Oh, that's a triangle, not an A. Okay. Now angle F was the angle below or to the right of our longer side, which for the larger triangle is going to be B. And then C. So there is our similarity statement. And the last part is to justify or explain your reasoning. We're going to simply say that this is SAS similarity. And that's it. And that will conclude this tutorial.